Hello everybody. This is Shinti Shaha from Department of Geography, Women's Christian College, Kolkata. I would like to thank you all for joining us. This webinar wouldn't have taken place without the inspiration from our principal ma'am, Professor Dr. Ajunta Paul, and members of governing body. I would like to request our honorable principal ma'am to inaugurate the webinar. Please, ma'am.
Thank you
Now
very
it's over
much,
to you.
Sheduli. It is indeed my honor to welcome everyone present here to the international webinar on climate change and urban environment, patterns, externalities, and mitigation, organized by the department of our college. The topic of the webinar, as we know already, is indeed a very relevant one, as it aims to address the ecological sustainability of our planet and, by extension, the survival of all created species, including human beings. Climate change, as we know, is a global meteorological phenomenon that affects urban life as rising temperatures lead to extreme weather events such as floods, droughts, and storms, increasing the spread of diseases. While the deeper aspects and technicalities of the theme, with its attendant ramifications, will be addressed by our illustrious speakers, I would just like to point out that the balance between human beings living in urban densities and Mother Nature needs to be restored through a restructuring of priorities. Man needs to be reconnected to his roots, his soil, and his environment in an integral and integrated way for local and global societies to prosper harmoniously. Before we can hope to bring about a change in nature, as all of us so ardently wish to, we need to think about the nature of change. By nature of change, I mean the sweeping and often reckless civic, demographic, sociological, and other changes that are being undertaken at every level in the world in the name of quote unquote development, and which are tilting, perhaps irredeemably, the precarious and delicate balance of relations between the human and natural world. We need, therefore, to awaken our conscience, or should I say, reawaken our conscience, reimagine the nature of quote unquote development, plan wisely, and envision the future holistically. It is indeed a very proud moment for us, with almost 600 participants joining in, either through the Google Meet platform directly or through the live streaming on YouTube. And I welcome each one of you. I especially welcome our two eminent resource persons, namely Dr. Chandana Mitra, Associate Professor, Department of Geoscience, Auburn College, Alabama, USA, who has so kindly consented to speak on the subject. It is late night at your end, Dr. Mitra, and I really appreciate your kindness in agreeing to this academic exercise at what must be an unearthly hour for you. Thank you once again, Dr. Mitra. I also welcome our other eminent speaker, namely Dr. Debujit Bhatta, Assistant Professor, Department of Geography, Chandipur University, who too has graciously agreed to share his expertise on the subject with all of us. I next welcome the members of the governing body of the college who are here with us. I welcome Dr. Raghu Pandey, Secretary of the governing body, Dr. S.K. Mukherjee, member of the governing body, Dr. Sulekha Kormakar, also member of the governing body. I especially record my thankfulness to the governing body members who are always there on our journey, by our side, a source of inspiration, helping us along the way. I welcome all the other distinguished guests, dignitaries, and well wishers who are present here today. I extend a most cordial welcome to all the faculty members from the various universities and colleges from India and abroad who are here. I welcome former faculty members and those of the alumni who have joined in. I particularly welcome the students from all over the country who, with their unbridled enthusiasm for knowledge, are present at this webinar. Finally, I welcome the entire faculty and non-teaching staff members of the host institution, along with the students of our college who are here to participate in what promises to be a most stimulating dissemination of ideas. I end with a prayer that this webinar be extremely successful and insightful as it opens up new areas of the ecological discourse and initiates fresh dialogues in the colloquium on climate change and its related issues. So once again, I extend a very warm welcome to all of you, and I thank the Department of Geography, the convener, Professor Yuti Shaha, and joint convener, Ruchita Gupta, and all the other members of the department for having had this brilliant notion of putting together, for organizing this seminar, and for, taking all the steps which are required to make this, to translate this vision into a fruitful reality. Thank you very much. Over to you.
Thank you, ma'am, for your valuable speech. Now I would like to request our secretary, ma'am, Dr. Rosna Pandey, to say a few words.
Hello, a very good morning to all of you. Can you hear me? I hope people, everybody present
Yes, ma'am.
can
A
hear
bit
me.
Ma'am, you are,
soft, could be a little
yes, ma'am,
louder.
you are.
Hello, a very good morning to all of you. I consider myself fortunate enough to have the opportunity to attend this very special international webinar on climate change and urban environment. The topic of the webinar is indeed an interesting one, as it is very relevant to the present world scenario. I congratulate the principal of the college, Dr. Ajanta Pao, for making the webinar a reality. I am deeply thankful to all our erudite scholars, the resource persons who will now enrich our knowledge by their address on the issues of urban environment and climate change. I express my heartfelt thanks and congratulations to the Geography Department of the college, its faculty members, distinguished teachers of the college, the members of the governing body, the honorable ones, the respectable guests present in the gathering, and my very dear students. I thank you all and congratulate you for your participation to make the webinar a reality and success. Thank you.
Thank you very much, ma'am. Now I would like to request Dr. S.K. Mukherjee, sir, member of our governing body, to say a few words.
Am I audible? Hello.
Yes, sir, you're audible.
Uh, at the outset, I extremely thank the management of the college, the principal, secretary, and the teachers who are involved in organizing this unique seminar on environment-related issues. Now, this is the trend of this in this pandemic hour to uh, to conduct seminars at different colleges through this webinar method, and indeed this is very helpful for all the students, interested persons, teachers, uh, being at the pleasure of their home and have the platform to to enjoy and be benefited through dissemination of information of the expert persons in this field. I am not an expert, just an listener to this webinar.
Thank you, sir. Uh, Thank you, ma'am. Thank you, sir, for all your encouragement. Now, I would like to mention the support from my department, encouragement from the teaching and non-teaching fraternity, present and ex-students from our department. Thank you all. A warm welcome to all our guests. Thank you for joining here this morning. I am going to introduce the topic of our one-day international webinar. You all know that our theme is climate change and urban environment, pattern, externalities, and mitigation. Human beings often forget that we are largely dependent on Mother Nature and become ignorant towards taking care of it. We have been so reluctant to the preservation of natural resources and sustainable development that we had forgotten the beauty of the earth completely. The COVID 19 lockdown imposed throughout the world has struck a chord in every one of us, and it has made us thinking how nature is so important for our day to day living. The tangible improvements in nature have made us believe that the earth can be saved. It has made us see that our actions can very well impact the earth's sustainability. For breathing pure air to greener trees, spotting various wildlife into the cities, here are some important environmental changes that we have seen for coronavirus lockdown in India. The theme is ideally very interesting in today's context. In one hand, we are under the threat of global heating and its consequent sea level rise. On the other hand, four positive effects have evolved out. Number one, improvement in air quality. Dolphins spotted near Kolkata Ghats after 30 years. Number three is the number of flamingos increased in Mumbai, and number four is Ganga is now fit for drinking in Haridwar. So we find a distinct change in air quality and weather pattern, which consequently may affect global climate, especially the urban environment in near future. Dr. Chandana Mitro, Associate Professor, Department of Geosciences, Auburn University, Alabama, USA, and Dr. Debojit Dotto, Assistant Professor, Department of Geography, Jadavpur University, will enliven us upon climate change and urban environment, throwing light on issues related to patterns, externalities, and mitigation. Hope the vibration and energy we are going to receive from today's discussion will help us to be more focused and involved in fighting climate calamities. Dr. Chandana Mitra has done her graduation and post-graduation from University of Calcutta and done her PhD from University of Georgia, USA. She had been a teaching assistant and research assistant in University of Georgia from 2005 to 2011 and presently posted as the associate professor in the Department of Geosciences, Auburn University, Alabama, USA. Dr. Debojit Dotto, Assistant Professor, Department of Geography, Jadavpur University, has done graduation from Presidency College, completed his master's from University of Calcutta, and pursued PhD from Indian Institute of Technology, Kharagpur. We would love to hear from both of you. Now, Chandana, it's over to you, please.
Thank you very much. So I'll go ahead and start the presentation mode. If you all can just be a little patient while I work around these things. I hope you can see my screen here. Dr. Shaha, can you confirm if you can see, because I can't see the Google Meet page anymore.
Yeah, it's clearly visible. No worry, Chandana, it's clearly visible. Please
Perfect.
proceed.
Thank you very much. Thank you. So good morning, everyone. It is. Thank you very much for joining, because as Dr. Paul said, that it is. We have around 500, 600 participants, and it is such an honor to come and get the opportunity to come and speak to you all and discuss certain aspects of urban environment and urban microclimate. But before I begin, I would like to thank Dr. Ajanta Paul to send out the invitation. It is really an honor, ma'am, to be a part of this webinar. It is because I am from Kolkata, so it's always a pleasure whenever I get an invitation from any university or any college or any of my colleagues in Kolkata to share some of whatever I've learned from Kolkata all through the years and also in the US. Past few years I'm working here. So thank you again, Dr. Paul. And I cannot move on without thanking my friend, my classmate, Dr. Shejuti Shaha. We have studied together, we have done our masters together. So I have to thank her a lot because she was the one who kind of organized this whole thing, sent out an invitation to me and Dr. Devajit Dotto. And I have to, thank her. I cannot thank her enough, I would say. I would also like to thank, and I know Dr. Shaha already has done it, her students and other faculty members who have been helping us to, do everything the proper way, like, do the projection on YouTube the right way and everything. So thanks everyone for, making this possible. So I will not go ahead and speak anything more about the title of the talk because that Dr. Paul and Dr. Shah already has mentioned, and I will not introduce myself again because Dr. Shah has done an excellent job and humbled me by the introduction she has done for me. So I'll quickly move into my talk. Before getting into the scientific part of urban climate, I would like to draw your attention to the center of the screen, which actually shows a certificate. So, before I started preparing for this talk, I actually went to the Women's Christian College website, and I was so happy to see, this one certificate which was kind of, showing up very bright on the first page, which is it's a Green Revolution Global Certification Program, and I haven't asked Dr. Shahado, but I'm assuming that faculty members, students, with the initiative of Dr. Paul, has been, gone through this program and got the certification. The reason I want to mention this is this kind of shows how the college is very progressive, because that's what is very important. My undergrad in Kolkata is from Gokhale Memorial College, which is also a women's college, and somehow I feel that when we want to educate and we want to progress a nation, a community, a city, and even I would say the earth, it's very important that we educate and empower women. And you have seen all the discourses and all kinds of discussions going on different, public platforms. So what Women's Christian College is doing, under leadership of Dr. Paul and with all other faculty members, I can really feel, which I missed when I was in Kolkata. I was actually involved in all kinds of activities. It is amazing, and it's very good to see how Women's Christian College is leading the path and making, these the young women in your college much more vigilant and much more aware of all the drawbacks and what all the things are happening around us connected with climate change and global warming. So I would also like to draw attention to the right side of this particular slide, where I would encourage everyone to read this book, which is Drawdown. The name is Drawdown. It is edited by Paul Hawken, and this book actually suggests 100 solutions by which we can reverse global warming. And they are very simple solutions, very, very simple solutions. But when Paul Hawken went around the globe, did a survey, they found that one of the most important things which came out from that survey is empowerment of women. Just like Women's Christian and many other colleges in India, and of course in the city I come from, Kolkata, where everyone is trying to educate more and more women. So they actually have found that if we empower women, if we educate women, if we give some rights to women, they can actually change your home, your community, your neighborhood, your city, your country. So it is, before I go into the scientific part of my discussion, this is something which really struck out to me when I went to Women's Christian College. And so I would really applaud the community and the faculty and the leadership of Women's Christian College to take these kind of efforts. So now, after this kind of introduction on the importance of women's education, I would like to kind of take you through the way we have designed the talk. And the reason I say we is because myself and Dr. Devojit Dotto, we kind of had a discussion and we decided that we will not do the typical kind of webinars we have. So a technical session one and a technical session two, and he's going to speak and I'm going to speak, and we're going to do it in our own silos, like separately. So we thought, let's do it like as if in a blended webinar. So what we have decided, we're going to talk about urbanization and impacts of urbanization, and I'm going to more focus on urban microclimate. And so the first section will be, I'll be talking on why cities matter, urban growth and its impacts, the urban heat and urban precipitation effects, then what we can do better to make cities a more livable place. And then Doctor is going to speak about the role of urban and peri-urban agro ecosystems. After we are done with both of our sections, then together we are going to talk about some of the resources, some of the open source softwares and educational and research opportunities, which you all there, all the 500, 600 participants, and many of you would already know some of this, but still there is no harm in getting reminded about them. And also the ones who do not know, we would like to enlighten you with some of these open source softwares and some of the research opportunities where you can go abroad and stay there for weeks and months and do research and get back to your own colleges and to your own institutions to expand on that research. So the other thing is that because we are not going to have breaks while we are talking, so please write down your questions, whatever concerns, questions, queries you have. You can post them in chat, which we can, either Dr. Shaha, myself, and Dr. We are going to look at the questions, and we will try to address most of your questions, but in the interest of time, we cannot maybe address all the questions. But please write the questions down and keep it for the completion of the talk, and then we'll get into the Q&A session. So after kind of giving you this, how we've designed the talk, I'll move on with showing you one of my favorite slides. This is an image which I generally, whenever I do a public talk, I always begin with this talk, with this particular image, because this shows the urban footprint on the face of the earth. And mind you, this is a 2002 image. After that, NASA did not produce any more of images which are more recent, but I still use this 2002 image because it is so, it's so prominent, where it shows all these, the urban, the white dots and the larger dots and the smaller dots. And I can assume that in this 18 years, most of these dots have kind of come together. Either they've become larger, the urban areas have grown, or there are more number of dots all around the earth. So this is a unique image which shows, very well how the urban area is spread along this whole face of earth. Also, I would like to bring your attention to this one petition by Dr. Paul Crutzen, which is very connected with what Dr. Shah and Dr. Paul both were mentioning about climate change and what we're seeing around us. So, and also even COVID-19 is this, he coined this term as Anthropocene, which means that we humans, just like geologic agents, like the water erosion and ice erosion and snow erosion and volcanic eruptions, we have become so prominent and so strong that we actually are changing and modifying things, the different processes, the physical processes, which actually move or motivate the different elements on the face of the earth, the way the atmosphere and the land and the ocean, they interact. We are able now, the humans, we are able to modify and change those too. So actually the Anthropocene age is, there's no particular demarcation, but I think that's a very important thing for all of us to kind of be more aware of how we humans are changing things around. Now getting into why cities are important and why they matter. So what I'll try to address here, as I mentioned earlier on, is why cities matter, how cities affect the environment, and what can we do to improve the impact of cities. Now in the diagram below, you will see I've got four, the global, regional, local, and microclimatic, which is very, very neighborhood scale. The reason why I had it, the main point here is that we always talk about global warming, we always talk about climate change, and we always think, the main discussion is how climate change, global warming is actually influencing, our countries and our cities, and how it's kind of making more of our neighborhoods less greener and more hotter, how we are using more air conditioners and all sorts of things we're always discussing. But it's actually a two-way process. Even what we are doing in our cities, the way we are polluting, the way we are cutting down trees, and all the concrete which we are just, happening to cut down the trees and replace them with concrete, all of that also has an impact on the region as well as the global aspect, because we are covered with one atmosphere. So whatever we are doing here locally in our city, say in Kolkata, or whatever we're doing Bangalore or Delhi or any other big city or medium-sized small city, every city churns its own germs. And so that also feeds into the atmosphere. So this whole, the feedback element is very much a two-way process, global to microclimatic or neighborhood scale, as well as neighborhood city scale up to the global. So that's a broad thing which I wanted to discuss before going into more on the urban scale. Now from here, before I get into a discussion, let me play this video for you, and hopefully it's going to play. Oops, sorry. Okay, so this is, just watch the video and how the city is growing. This is from 1972. It goes into 2010. Now, as you're watching, I'll just kind of, give you a brief introduction, sort of of what this is showing. This is a city in the US, and this city actually should not have been built in this location. You can see around, it's pretty dry, it's mountainous, you don't see much of greenery around. So it's in a very dry area. It's growing exponentially, and urban climate scientists, as well as just general scientists who are working with climate change, we are very concerned about the city. It's around. I'd like you to see that the gray areas all are urban areas. But the fun part is that this is again a NASA image, remotely sensed time series, which shows that the red ones are actually urban agriculture. And this is something which Dr. Datta is going to speak about. So this urban agriculture means when we are transforming these natural surfaces into forested areas, or transforming them into mostly into agriculture, because we have to feed so many mouths. As the city is growing, we have more mouths to feed. We have to grow more and more crops. And this is a very dry area, so we're growing them right around that city. Now, and because I don't have the scope of asking you questions and getting answers, because everyone is muted, so let me go ahead and tell you what the city is. The city is Las Vegas, and it's a very popular and renowned city. We have seen all, in Hindi movies, we have seen heroes running around and spending money. This is one of the richest and a city which makes people just outrightly overnight poor, because it's a gambling city. But this city, Las Vegas, is absolutely a city which has been developed just for financial, economic reasons, but not thinking about the environment. And that is what's happening in most of the cities around the world, right? Still, I'll continue kind of, explaining more of, giving reasons why cities do matter. So if you look down at the slide, every week, 1 million people get added to cities. 1 million people every single week. Today, 55% of the world's population lives in urban areas. It's expected to increase to 68, approximately 70% by 2050. 1975, 3 megacities. 2018, 31 megacities. 2030, the prediction is, the UN, United Nations projection is 43 megacities. And we are actually growing. We are very fast getting to that number. They're not far away. We're just 10 years away from that 43 megacities. We're already there, right? So this is the reason why we have to think about cities. We cannot ignore. We just cannot think that, oh, cities are so much fun. We have malls and different new shopping complexes coming here and there. We have the metro. We have all kinds of goodies in the cities. We rarely think about what the reputation or what this influence of these huge cities are having on the environment around us, and actually we'll see how it affects. In the next slide, it also affects our health, which we always tend to ignore. Now, I've made a list of this, trying to show what the hazards and the risks are in urban environment, and I'm sure most of you who are listening to the webinar are not unaware of any of this. So we actually face it, be it in Kolkata, be it in Bangalore, because I know there are some of our colleagues and friends and students from other parts of India and also, from other cities. Uh, Everyone's kind of, if you look at the whole list, we absolutely we do encounter some of these, not all, but some of these. So first one is poor air quality, and the fun fact is that urban areas actually produce 70% of the greenhouse gas emissions, just urban areas. We have extreme heat and cold events, and that actually leads to human thermal stress. We know, like every year, I can hear my family and friends telling in Kolkata, oh gosh, this year is the hottest. This year is the rainiest. This winter is the worst. But they forget that the previous one was equally bad, but it's becoming worse and worse and worse every single year. We have, more intensive hurricanes and tropical cyclones. We have seen what's happened with Ayla. We've seen with Amphan. We've seen the kind of, all the destruction brought in. We have extreme local winds, wildfires, sand and dust storms, which may not be very common for every single city, but in Delhi we have dust storms, urban floods, sea level rise due to climate change, energy and water sustainability. We're using a lot of energy, and a lot of cities like Cape Town and also Bangalore is on the list, which is going to become a very dry city in the near future. Public health problems, mental health. Think how irritated we all are just because of this urban heat and all this, this waterlogging and all the different air pollution. We're always talking about those things, and it's and a huge mental stress because of that. And then this new phenomenon, and new, not actually new, it's like 10, 15 years, 20 years back, we're having this whole concept of environmental refugees. So the coastal cities, which are hit by tropical cyclones like Amphan or Ayla, they can't, they lost everything. They can't live there anymore. Livelihood is gone, so they're going to move on to either higher land, which is mostly towards the bigger cities, and that is a huge pressure for the cities because they already are, under that. They are like pressure cookers. They can just kind of blow up anytime, and then we go on adding all these environmental refugees on top of that. So these are, and this doesn't really exhaust all of the hazards and the risks which we face in urban environment. And now we have even we can see the locust problem which happened this year, all along the western part of India and into Uttar Pradesh and even beyond. So we have a plethora of this, numerous other factors also which kind of are hazards and risks for urban environment. But so we now know that we have a lot of risks and hazards. We know that urban areas are, we have to take care of urban areas. We have to look after them. But what is happening? What is actually happening now? This image is more like a textbook image. So some of you may be already knowing or have seen this image earlier on. But again, just expecting that, assuming that most of you are not, all of you don't have a geography background or don't have an urban climate background. So there will be some of these basic science images here. So this one actually shows you the left-hand side of the image. And don't look at the red arrows because that's the sun's radiation, the sun's rays coming in and the ones which are leaving the earth. So I'll ignore the red ones on the side. Let's look at the blue and the black and the brown one in the left-hand side image. That's latent heat, which is the heat which is hidden, which is kind of stored around here, which is used for evapotranspiration, for condensation, and all those processes. And then we have sensible heat, which is the heat we feel on our bodies, on our skin, like a hot day, a cold day. That's sensible heat. And then we have storage heat, which is the heat which is stored, absorbed by all the elements on the surface of the earth. So now what happens is we are cutting down the trees. The trees are gone, and we're replacing the trees or the plants with concrete. Buildings and parking lots, shopping malls and whatnot. And then we now look at the image, beside the image which is to the right of the image. There you'll see the blue arrow. It has increased. It has decreased by 1 point, which means urban areas are much more drier. It doesn't have much more moisture. It doesn't have latent heat. The sensible heat has gone up by 0.2, which means we're feeling much more hot. The urban heat has increased. Look at storage heat. Because of all the buildings and the concrete and all the metals, cars and buses and everything, the asphalt roads, the storage heat has gone up by 1 point. Huge amount of heat is stored in urban areas. And again, there is this new element in the equation, is a green line, which is the anthropogenic heat, the human heat. which I produce, you produce, your laptops. Now we have like 400 laptops open. So imagine just 400, 500 laptops. How much of heat is that generating? If you put all of those laptops into one room, that is anthropogenic heat. The heat which we produce because we are running the air conditioners, assuming the Kolkata is still hot, with bouts of rainfall though, but still hot. So people are switching on the air conditioners. Imagine the amount of heat produced because of this air conditioning, or the heaters, or the air coming out from different factories, industry. All of this is anthropogenic heat. Now, what's happening in urban areas is, if we put together the sensible heat, we put together the storage heat, and we put together the human heat, what it produces is this urban heat island intensity, or just an urban heat island, a blob, sort of a roundish semicircle over the city. Now, again, some of you would be knowing urban heat island intensity. It's a very commonly discussed thing, even on media. What is it? It is the temperature difference between urban and surrounding rural areas. Generally, on an average, it's between 5 and 7 degrees, but it can go up to way over 12 and 15 degrees difference between urban and rural areas. You've seen in summer in India, there are so many, we have heat waves, and mostly in the northwestern part and in the central part, some of the cities, they reel under this urban heat element. And people get sick, people die. When I was growing, and I can't speak to people, but like, Dr. Shaha Shejuti can, and when we were growing up, like in the 90s, we never spoke about urban heat and how people are dying in India. But in the past 10, 15 years, we are seeing that every year those numbers are increasing, and it's becoming worse and worse. The conditions are worsening in every city around in India. And even people from Bangalore, my friends there, they always say, oh, now we have to, once in a while, we have to switch on our air conditioner, which was unheard of in Bangalore. So that's what urban areas do. The more amount of concrete we just kind of inject into an urban area, this urban heat island intensity is going to go up. Okay? For example, I live in a very small city. It's a university town which has around 20 lakh people or so. Even that city, it's a medium-sized city. That city also has an urban heat island intensity of around 4 degrees or so. So every other city, small or big or medium, all around the world have their own urban heat islands, right? So that's very important to keep in mind. Now, what are the causes? Of course, the asphalt and the concrete, the black tar roads, all of them, they absorb a lot of heat. We have less number of trees in cities. We understand that because, assuming most of you are, either you visit a city or living in a city. Then lot of human heat. Weather, if you have cloud, then it's going to be a heightened urban heat island intensity. If you have no wind, that day the urban heat island will be the intensity will be much more higher. But when you have wind, it's going to dissipate the heat. So it's going to be lower. So no wind, higher urban heat island intensity. Then of course the greenhouse gases, a lot of greenhouse gases and aerosols and water vapor, everything, around in and around the city. Then we have the surface geometry, which we don't always think about. As urban areas, think of the CBD area or the downtown area. It's full of buildings, and some of them are beautiful, tall buildings with glasses and metals and concrete and everything. And they have the number of faces are maybe sometimes 4. Then you have all these designs, and they have more faces. So the surface geometry is very complicated in urban areas as against a rural area. It's pretty flat. So in that case, what happens is the more surfaces you have, the more radiation is absorbed and then emitted back after the sun sets. So that creates a dynamics between buildings side by side or buildings far apart that creates this urban heat island over any city, right? And I won't, on the right-hand side is another image from Atlanta. And sorry, I have more images from the US because my research is kind of connected here. So this shows, and this blue line there on the extreme right-hand side is albedo, which means the reflectivity of any surface. How much a surface can absorb and how much it reflects. That's albedo. And the blue line is a highway. And you can see that because it's black asphalt, how much of the heat is absorbed by that highway, which is the blue line all in the middle of that image. This shows what happens in an urban area. All the blue lines there are mostly, they're concrete parking lots or they are streets. So that's what urban heat is, how much of absorption happens. Now from heat, I will move on to water cycle. Now this is a kind of research which I have been doing for a while, along with urban heat. And so I wanted to share something about this, is that urban areas actually even modify the urban water cycle. Now I'll bring your attention to the left-hand side, this image. Again, the top one is natural surface, where we just have trees and plants. Here you will see that 40% of that is evapotranspiration, where the water is evaporating from the leaves and from the ground, everything's going up, 40%. Surface runoff is only 10%. Most of it is getting infiltrated into the soil, And you can say 50% is getting into the soil. We need that because we need more water to replenish the groundwater, right? Because we are pulling out so much water. But that goes away when you replace those plants with concrete. So the bottom one, actually, see how the dynamics, how the equation completely changes. So in that one, the evapotranspiration reduces and becomes 30%. The surface runoff increases and becomes 55%, which is huge in comparison to the top one, which is just 10%. And what happens? All the surface runoff goes into pipes or goes into all the concrete drainage system and goes into rivers and all other water bodies. But then there is a feedback, a negative feedback, a lashback from them. Say, you see what happens in Kolkata, and every year we see what happens in Mumbai, because all the drains and all the rivers, all the water bodies are filled up. So there's water coming back. So more surface runoff, there's a lashback, and there's waterlogging or urban flooding. And what reduces is the infiltration. It's only 15%. So in concrete areas or in cities, we are pulling out huge amount of water from the groundwater table, but we are not replenishing it because only a little section of that is going into the soil. Because there's no soil. There's very limited soil. Most of it is already concrete, right? Now after that, I would like to...
Dr. Mitra, can you hear me?
Yes.
Devojit, your presentation is not visible actually. You please change to your presentation mode.
Really?
Yeah.
Uh,
Sorry to interrupt.
But I can
No,
see,
sir.
but I can
Sorry to
see
interrupt.
the presentation.
can someone...
visible.
It is visible. So Devojit,
yeah.
for some...
Okay.
Devojit, for some example, for some reason you cannot see it.
Yes. I cannot.
No, ma'am. The presentation is not visible.
Actually, when
Please
somebody
pin
was
to
presented,
You please pin to Chandana's presentation. You will get to see. It's visible.
the presentation is visible, but in a brief form. Okay, not in a not just.
So what happens is on Google Meet, what happens is you get to see other faces, but you see the presentation it's much more on a smaller scale. So you won't be able to see the full screen. Am I right?
No, Chandana, please, it's not in full screen mode actually. It is in
Okay, now
presentation mode.
I will put it into full screen. Is that okay now?
Yeah, it's okay. Perfect.
Right.
It's perfect now.
Right. Thank you. So where was I? Okay. So I was trying to say that because urban rainfall is modified by cities, so I would like to show you some of the reasons, the different ways in which an urban area actually influences the urban rainfall pattern and the different the disparities in the urban rainfall. So the first one, what happens because we have a city, the first thing is, again, if you see the red marking there, it's an urban heat island. So there is atmospheric destabilization because the city is there, the air becomes unstable, it becomes buoyant, and there's low pressure over the city, a little low pressure, not too much of a difference. But what happens is the air comes in and there's convergence, and because of the convergence, that particular part of the air has to rise up, and convergence in this convection, and there is cloud formation. Not every time, but in some cases. So sometimes cities actually generate their own storms. And this was first in around 1920s. This London was seen that London was creating its own storm. And the example I have here on the left-hand side bottom is from Atlanta. And numerous cases, we have seen that Atlanta has produced or generated its own storm. So that is very unique, right? Just hold on a minute, please.
Dr. Vishnu, please unmute yourself.
Okay, sorry everyone. I actually was called by Shriruti because there was some problem with the presentation mode, and some of you all who are watching from a cell phone couldn't see my presentation. You could hear me, or some of you could see the smaller version, but not the larger one. So I'm sorry about that, and sorry for the disruption. These are one of the glitches of doing anything online. So hopefully you can see, this particular slide where, Shrediti, can you see this? The atmospheric destabilization, the number 8, that slide?
Now it's perfect, Chandana. No worry.
Thank you. Okay, good. So what I was saying is, and you have heard me, so I will not repeat, but because we have this urban heat island, so it there's air comes in, converges, and there's convection, and it may form clouds and give rain over that same city, or sometimes downwind of the city gets more rain. So that's one cause, one reason, or one way in which a city influences the rainfall pattern. The second one is the roughness. So when a gust of wind comes in, or when a storm comes in, and then we have the roughness, which is because of all the buildings. Think of the CBD. Every city has a CBD. So the CBD and all the different facets, and the big and small and tall and wide buildings, they cause roughness in the path of a storm. So the storm comes in and it kind of slows down. There's convergence. Sometimes there's uplift, and there could be rain, and then goes over the city and again accelerates, becomes fast, and it could give a lot of rain there. So that brings in a modification in the pattern of rainfall in a city. The third one is very important, which is seeding, which is, there's a lot of text here, but what the main crux of this whole text, all the text is aerosols. If you have more aerosols, it actually helps in modifying the rainfall pattern over a city. And the next one is, so still there's a lot of debate going on as to if aerosols are increasing or suppressing rainfall. So on the left-hand side, you would see, because if you have more aerosols in the atmosphere, urban atmosphere, it's going to block the solar radiation. So some of the sun's rays cannot come to the surface. And that actually reduces the urban heat island intensity. And that in turn will influence the rainfall forcing. It can increase or decrease the rainfall amount. On the right-hand side is another aspect, which is all these aerosols can become cloud condensation nuclei, which I assume geographers know, because every single droplet needs an element to condense on. So those are called cloud condensation nuclei. So these aerosols form cloud condensation nuclei, and they form these small little droplets, but they never or rarely do they become rain drops, like bigger drops and heavier drops. They do not come down to the surface as rain. So you can see there is this debate going on if whether aerosols, urban aerosols, actually suppress or enhance rainfall. And the jury is still there, out there. So scientists are still kind of debating on that. And the fourth one is just the sheer presence of a city, like sitting like a blob there. So when you're running and you come across a stone, what you do is you either run over it or you go around the stone and move on. So when a storm comes in and it suddenly comes in touch or hits a city, it doesn't know what to do. It's rarely can it go up the planetary boundary and then move on. So what it does is mostly these storms, they come, and this is an example from New York. The storms come in and they split into two. And this has been done in numerous cities, Indianapolis and other places too, and others, in Beijing. Many other cities, this research has been done where the storms have been seen to split. Sometimes they may meet and become much more pronounced and enhanced, but sometimes they just split and go two ways. It's called the barrier effect. So we see the urban heat island, then just the roughness of the city, then the aerosols present, and just the mere presence of the physical presence of a city. These four elements play a role in changing or modifying the rainfall element in urban areas. And all of this we've seen in Kolkata and other places. One area it rains on, the other area is dry. It could be just because the city is expanding so much that when we travel from point A to point B, we're crossing, spatially we're going through a lot of distance, and so it may not rain. So these all kind of spatial variations is explained by these different factors, these four factors. Okay, so I hope I'm doing good with time, and quickly I'll finish up this talk so that Dr. Doctor can speak. And these are other two elements, which is, cities are much more drier. So this is New York, Washington, D.C., all the blue areas are cities which show they're way drier than the surrounding areas. And the other one, which is also very dear to people who are living in Kolkata and now in India, because we see so many flash bounds. In the recent past, a number of research has been done showing that urban areas actually attract more lightning. And the number of flash bounds are way higher. This is an example from Atlanta, where you can see the dark brown patches. That's where there are more flash events and more flash bounds, lightnings, are reaching the urban surface more than the surrounding rural areas. So these are some of the microclimatic changes which are occurring because of the growth of a city. Okay. Now next is, I cannot do a talk in Kolkata or a college there without talking anything about Kolkata itself. That would be just not done. So I would like to show you some of the research which I've done earlier on, and some is ongoing, but not too much. But this is from earlier on, what I've done. And this is how the city of Kolkata was, and this is mostly remote sensing images, and then I put those remote sensing images into Idrisi Selva cellular automata model, which has spit out how the city will look in 2025. And I will have to, maybe in 2025, it's just not far away. And you can see that, maybe I have to do a comparison, and you can see that the south and the east and the southeast is actually kind of matching up to what we see in 2020. So this is what the predictions are for the city of Kolkata, and we're seeing how city of Kolkata is growing pretty fast. On the left-hand side is, again, Kolkata urban heat. This is a MODIS image spanning over around 20 years, and you can see the urban hotspots. And I can't zoom in to show it to you, but I know, because I've seen the image full screen, is that the intensity, the orange and the yellow and the orange, that has actually, the intensity of color has increased when it comes to the image number B. And also the area has expanded to the east and to the southeast. So that is kind of shows the urban hotspots of Kolkata city. Now on the right-hand side is an image which I've plotted using the TRIM satellite data. It kind of shows over Kolkata, there's a convective event happening over a rainstorm. And you can see how over Kolkata it's very orangey and yellowish, which means more rain is occurring than the surrounding areas over the city of Kolkata. So it very well fits in with that, the one or two elements which I have discussed, how cities influence rainfall. The next one is a research which me and my student, we did earlier on using the WARC model, which many of you have used. I know some of my colleagues have used this. And so this one is accumulated rainfall. It shows that, if there's a if Kolkata, like with Kolkata, and these are runs done with Kolkata and without Kolkata. So in case it's with Kolkata, it shows that the amount of rainfall is more when we have Kolkata. But if we would have removed Kolkata, which we have done in the model, rainfall would be less. Similarly, on the right-hand side, the sensible heat, the urban heat, is much more in when we have Kolkata, but it's much more reduced when we remove Kolkata from that model run. Okay? And here, which actually fits in with what Dr. Datta is going to say, is uh, this is East Kolkata wetlands, which many of my colleagues have worked on. And this is a little bit of contribution from my end, which shows that the wetland to built up has increased quite a bit from 1970 to 2011, and including the wetland to cropland, which is the peri-urban thing which Dr. Datta is going to speak. So that is very important, where how the land transformations are happening, how the land cover is changing because of population pressure, because of the growth of the city, because we need more food to feed the mouths, and we need more area to build and to house all this population coming into Kolkata. Okay, now quickly, I'll move into what we can do to reduce the heat and to reduce the flooding incidents in cities. The first mitigation measure, and the easiest one, pretty inexpensive, and many of the cities, like I know, places in Singapore, Hong Kong, New York, and many other cities all around the world are trying to utilize this, paint the roofs white. And you can see on the left-hand side, the temperature difference, if it's a gray asphalt or a black asphalt, it's around 48 degrees centigrade, but when you color it white, it becomes 28 degrees centigrade. So you can see how you're not going to use too much of air conditioning if you have a white roof as against a dark asphalt roof, right? The next one is having cool roofs or green roofs. At the bottom, this is an example from Chicago where they had a roof green, or all green plants there, and then a black asphalt. And you'll be amazed to know that the temperature difference was 40 degrees centigrade between the green roof and the black asphalt roof. 40 degrees centigrade, which is just enormous. So imagine the amount of energy which is required to cool the rooms below the black asphalt roof, as against the amount of energy required for the ones which are under the green roof. So that is what mitigation measures are. And many cities, again, are doing it. They are way ahead, in the run. Now, this was a study which was a paper published, led by Dr. Chatterjee from Presidency University, and I happened to be a part of that paper. So this one actually speaks of that we cannot have one equation. We cannot fit everything into under one equation. What the mitigation measures which we are going to use for tropical areas, for places in India, may not be applicable to places in Canada. Or what we are choosing for Canada may not be applicable for places in the tropical areas. That's very important. You just cannot use a cookie cutter and use the same mechanism for every city all around the world. You have to actually look into the local microclimatic elements and the surrounding if we have to use any of the mitigation measures. That's very important. Then, of course, more and more, any kind of green infrastructure is always welcome to reduce the urban heat island impact or the intensity. Next, because we have been talking about urban flooding, so I would like to kind of share a few of these, infiltration trenches, vegetated trails, bioretention cells, and also rainwater harvesting, which is very important in many cities in India. In Chennai, actually, they tried a lot. It somewhat failed, but still they're gearing up. Now, good with urban rainwater harvesting. Research which we did here in Auburn, and we saw buildings. And I hope many buildings all over India are going to choose doing this, is gallons, millions and millions of gallons of rainwater is saved if you do rainwater harvesting. It is not very expensive, low maintenance, and huge amount of awesome. It's great. So it is recommended that people in urban areas go for rainwater harvesting. And then, of course, urban agriculture, that's also one thing which Dr. Datta will allude you on, is some of the water is also kind of sucked in by this expanding urban agriculture too. Now, so these are some of the elements which we can use to improve the impact in cities, and I will not go through them. The right hand side is all the intervention we can do to improve the conditions in cities, and I would let you read through it. But I would like to end this part of my lecture by bringing your attention to a very important thing. So what happens is, me as a professor and Dr. Datta and Dr. Shah and many other colleagues I know, my friends and colleagues, my classmates are here. We are all doing our bits and pieces. We are all publishing, either we are teaching our students. Rarely do we see, rarely, and that is already published, rarely do we see science transformed into action. We always publish, we kind of teach our students, but just like I showed you in the beginning, that certificate which students of women's Christian colleges got, that is what is action. So you have to learn, and then you go out into your community, into your city, and transfer your knowledge to the community. You can use multimedia, you can do so many things. Like today we are reaching out to 600 people. That's unimaginable, and that's amazing that many people are hearing us, our discussion, what we're doing, and that is knowledge transfer. Very, very important. The other thing is interdisciplinary research, collaboration, which I don't think we do too much amongst scholars. It's very important because we cannot do it all alone. We have to work together if we have to make any changes to our research or to the globe or to our city. And then end my talk by this urban integrated services, which is promoted by World Meteorological Organization, and I'm a part of this particular initiative, where they all talk about it. Stop working in your silos, come out, collaborate, do things together, go and talk to the government, to the stakeholders, even to the grandmothers, to your neighbor. Just talk about climate change, talk about what different things you can do, and bring the change. Start from your home. Try to make a change at home and then transfer it into a broader audience. So thank you very much. Thank you for bearing with me and listening me, hearing me out all through these whatever number, I don't even know how much time. I move it on to Dr. Datta to continue with his presentation.
Thank you, Chandana, for your wonderful, well-researched delivery. You have touched almost all aspects of climate-related hazards like environmental refugee, depression of groundwater, urban heat island, hotspot, sensible heat fluxes, carbon footprints, and many more. The best part of your talk was probably the mitigation part. So easily we can address few problems. May not be all. We are really enlightened. As you have already said that he will take questions at the end. So I would like to request Dr. Debojit Datta to present his work. Debojit, now it's over to you.
Thank you, Dr. Shah. Can you hear me?
Yeah.
Yeah. Okay. Thank you. Okay. Good morning, everyone. I hope you can hear me. It is actually an immense pleasure to me to present my whatever research work I do in this international webinar, and I especially thank Dr. Ajanta Pal, Principal Madam, all the honorable members of the governing committee, and Dr. Srejuti Saha and Srimati Sanchita Gupta for giving me this opportunity to speak here. As we all have seen that the topic of this, 1 minute, can you see my presentation? Dr. Saha, please say whether you can see my presentation or not.
Now
I can. Presenting. It's
Okay,
you are
okay.
presenting.
Okay,
But
thank
it's
you.
not really visible right now.
Okay. Let me see camera. I think now it is visible.
Yeah.
Okay, thank you.
It's
So,
clearly visible.
yeah. Okay. So, in the title of the topic, there are three important aspects that with respect to climate change and urban environment. These three are patterns, externalities, and mitigation. Now, Dr. Chandana Mitro, she has extensively dealt with these patterns and mitigations of urban climate change. I will rather focus on the aspect of externalities, specifically with respect to urban and peri-urban agriculture. Now, in developing countries like ours, whenever we mention about agricultural activities, uh, we generally do not treat it as a part of anything part of urban. This perception is both from common people or say government authorities. Everybody alike, they think that it is not part of urban. It is something beyond the common common perception of us about the urban environment. Even for some people, it may be a nuisance in their built up neighborhood. But at the same time, there are increasing demands for farm fresh vegetables, for local breed of fishes, for non-genetically modified livestock. So these are actually from where they will come from if we do not permit agriculture in our vicinity. So these are actually leading to a dichotomous situation. To me, it is almost like a curious case of urban and peri-urban agriculture. Should agriculture be part of the urban environment? Is it external or internal to the urban environment? If it is internal, what role does it play? And what are its relationship or its sustenance with the management of urban environment? In the next half an hour, I will try to discuss or elaborate on these aspects. So before going into the depth of the topic, I would like to first make it clear the definition of peri-urban. The peri-urban area is actually a transitional area between, say, the core urban area and its rural hinterlands. There are many definitions of this peri-urban, and there are debates also among the scholars. The Organization of Economic Cooperation and Development, they have given an all-encompassing definition. They mentioned three aspects: one from its place or location-based one, another is the prevailing processes, and third one is the concept or perception in people's mind. According to them, this peri-urban area is such an area where more number of the number of urban activities are more than the rural ones, and at the same time, the land use is a mixed one, comprising both urban and rural characteristics. And the third, but I think it is the most important one, the socio-cultural fabric of that area, of the residents of the area, these are becoming increasingly more urban. So by these things, I think you can have an idea about what peri-urban actually means. So is this area suitable for agriculture, or should we use these areas only for built-up expansion? In an urban setting, we do not generally do any activity which is not economically conducive. So we have to think of the economic value of this particular activity. As we all know, and Dr. Mitra has also mentioned, that urbanization has actually one of the most prominent human activities since the beginning of 20th century. Forget about the developed world. Even within the developing parts of the world, say South America, it is more than 60% urbanized. Asia and Africa, they are also cropping up. In our country, that is India, almost 30% of people live in urban environment. Although percentage-wise, it doesn't look that much. But if we consider the population base of 1.33 billion approximately, the number becomes huge. The number of people living in urban areas, the urban dwellers. So with this huge growth of urban population, there is a huge growth in the demand of, say, proper housing, proper communication technology, proper transportation facilities, industries, and there is also a tremendous pressure on the urban environment. How can we manage the urban environment in this kind of condition? And as the demographers predict that up to say 2050, the population is going to rise at least So how will we cope up? So as the problems grew, scientists and urban planners, they also came up with various sorts of ideas. And Dr. Mitra has dealt with these things. Cumulatively, all these ideas can be summed up in one term, that is urban green infrastructure. The urban and peri-urban agriculture, that is the abbreviation is UPA, it is actually an integral part of this urban green infrastructure. Since the 1990s, several international environmental bodies, the non-governmental organizations, the funding bodies, prominently like say, Food and Agricultural Organization or UNESCO, UNEP, everybody is actually promoting UPA. So what is the reason that UPA is given so much importance? Let's look into that. Whenever we mention about agriculture, the first notion which comes into our mind, that is of productivity and food security. Everybody understands this, that agriculture is primarily needed to give us a minimum security of food, the supply of food, whether we live in urban areas or in rural areas. Most people are aware of it. But when we think of the environmental services, the ecosystem services of agriculture, many of us may not be aware of that thing. In an urban area where it is very difficult to find a natural landscape, suppose a forest or a wetland, in absence of this type of natural landscapes, agricultural play, you can say it is a proxy to the natural landscape elements. These agricultural landscapes have tremendous role in supplying atmospheric oxygen in these urban microclimates. It has a role in recycling the nutrients. It has a role in maintaining the soil moisture. In some areas, it is used for wastewater reclamation or wastewater recycling. There is another very important aspect of this urban and peri-urban agriculture. That is, it is a storehouse, or it acts as a habitat of numerous kinds of biodiversity, both floral and faunal origin. This biodiversity aspect is increasingly gaining importance. So there are two types of, you can say, ideas about urban and peri-urban agriculture. One is emanating from the say classical economic point of view, another is coming from the ecological point of view. There are social and cultural values of agriculture also. People are attached to it. People have myths, their religious beliefs, their traditions attached to it. There are cultural activities apart from this, say, even from rural activities, social activities, there are cultural activities also. So all of these aspects together, UPA has a broader dimension to play in an urban and peri-urban setting. If we take the second definition, that is the broader definition, instead of the classical view, we actually point towards the concept of agro-ecosystem. Now let me elaborate on this aspect. What is an agro-ecosystem and whether UPA is an agro-ecosystem or not. As you can see, there are two parts of the same word, agro and ecosystem. That means at one end of the spectrum, it is an agricultural activity. It has some productive values. The other end, it has some ecosystem potentials. If there is a perfect balance between these two things, then we can say that we are moving towards sustainable management or sustainable development rather in the long term. This broader definition actually talks about the multifunctionality of urban and peri-urban agriculture. When a particular land area performs these multifunctional activities, then this can be treated as agro-ecosystem. And this is not, say, fixed in space and time. It varies in scale, both in temporal and spatial. When we analyze a single plot, a particular plot that is very small in spatial scale, that can be analyzed for a time frame of couple of years. But as you can see in this slide, this particular plot is part of a bigger farm, and this farm may be part of a bigger agricultural landscape or a part of an urban landscape. In the very large scale area, very small scale area compared to the single plot, which is a large scale thing. This landscape level study has to be done in an interdecadal time frame. So in both space and time, this agro ecosystem varies, and there are interactions among these type of scales. So all these things make it very complex to study. But one thing can be considered as a take-home message, that if there is a, say, checkbox, and if I find that all the activities, that the multifunctional activity roles have been filled up, have been performed by that particular area, that is which is under my investigation, that is performing all these multifunctional activities, then it is taking the shape of an agro ecosystem. It's more acting towards a sustainable agro ecosystem. But in the other end, if it is failing to perform these multifunctional activities, then it is taking the shape of a, say, degraded cropland, maybe a wasteland, if an extensive agricultural activity is going on in that area for decades with harmful environmentally harmful technologies. We all have experiences regarding this type of extensive or commercial agriculture without any thought given to the management of soil, water, and plant. Even in US also, they have experiences 1930s, late 1920s and 30s. We are experiencing it right now. So management of these fragile environments is highly imperative. If we think of, say, our country in particular, or the developing countries in general, there are several types of threats or vulnerabilities present for these urban and peri-urban agricultural activities. If we ask anybody, they will say obviously the most potent threat is coming from more economically dominant land uses, like built-up expansion, like say dairy farms, like say aquaculture activities in cities like Kolkata, or say the coastal cities like Puri or something. But when we went to field, particularly for Kolkata, we found that the prime reason is not this competing land use. It is there, obviously it is there. There is another important fact that is that can be easily summarized from the economy. The students from economic background can understand it very easily. That is from the law of diminishing return. Because of these faulty practices of agriculture for year after year, our lands are losing their fertility, and the agricultural production is becoming lesser. And at the same time, our families are getting bigger. Every household is getting bigger and bigger in size. So there are conflicts within the households, within the communities. So lands are getting fragmented. There are smaller plots, and it is very difficult to practice sustainable agriculture in those smaller plots, because with smaller plots, your capital to invest in those plots are also becoming lesser. But the most important fact, even regarding this diminishing return aspect, is actually the lack of proper implementation of existing legal frameworks. The government or the authorities, whatever form of government is that, whether it is under the corporation or say municipality or notified area or panchayat, there is failure. Throughout India, there is failure in conserving these agricultural lands. People will convert, because people, if unaware, because of their need to survive, and people always think of short-term gains, so they will try to convert these lands if they are not properly aware, or if they are not thinking of long term. But the role of government is not at par. Obviously, we are comparing with developed countries. In developing countries throughout the world, the situation is more or less same. So the prime threat is coming from, it's not that the legal frameworks are not present. There are stringent laws against land conversion, but on ground, they are, most of the times, they are not properly implemented. So these are the threats. And As I was talking about the city of Kolkata, that we did our primary field work in Kolkata only as a case study. So what is the situation of Kolkata regarding the development is urban and peri-urban agriculture? Let's see what is the status. Maybe there are some students not from geography background here, or some persons who are outside Bengal, not familiar with the condition of West Bengal. Whenever we say Kolkata metropolitan area, that is much bigger than the Kolkata Municipal Corporation, denoted by that dark red color. Kolkata metropolitan area is a bigger one. Suppose this is Bhagirathi Hooghly river. In the left bank of the river, it extends from Kollani to Bajbaj, and in the right bank, it's Bashberia to Uluberia. This whole area comprises, is comprised of, say, 4 corporations, several municipalities, notified areas, cantonment boards, and panchayats. So in a classical geographical concept, regional geography concept, it is a perfect example of a city region where we can find both rural and urban land uses together. So this makes it a perfect setting for studying urban and peri-urban agriculture and how much they are sustainable. So we tried to study these things. Primarily, we made a land use and land cover analysis, multi-temporal land use and land cover analysis. It is actually made by one of my students, and he also ran one simulation modeling incorporating several variables to see what will happen in 2030 if all other conditions remain constant. So I will just suggest you to look at 2 aspects without going into much detail. First one is the steady growth of built up areas, this reddish color thing. And Dr. Mitra has also mentioned that the most amount of growth is in the eastern area and southeastern part. Another important aspect is the gradual obliteration of the wetland areas, primarily denoted by the East Kolkata wetland in this area. There are other wetlands also beyond East Kolkata wetland. Whoever is familiar with the terrain, for them, it is up to, say, Ghatakpukur or Maloncho, up to that area. There are number of wetlands. But as you can see, with the progress of time, these wetlands are first getting fragmented, then they are filled up, and ultimately they are converted into other land use types. To our surprise, the amount of total cultivable land, here it is denoted as cropland and yellow color, it has not changed that much throughout this period. It may look like an anomaly, but the fact is that when we studied in depth, what we did, we made several buffers around the city core. This is the core city, that is the Kolkata Municipal Corporation. Around that, we put buffers of 10 kilometers as proxy to, say, this suburb area, urban fringe area, urban periphery, and then rural fringe area, like this, and then beyond that, rural hinterland. We just tried to apply the textbook concepts in the case of Kolkata. And what we found that although the total amount of total cultivable land is remaining almost same, but the intra-zonal dynamics are changing. In the areas near the urban core, built up is actually engulfing the agricultural land. It is growing up by taking agricultural lands. But in the outer areas, that is, say, rural fringe, urban periphery, and even in rural hinterland, agricultural land, that means croplands, are growing by consuming up other so-called natural land uses. Natural land uses, it is actually a dubious term, but we are using here this term to denote, say, natural vegetation, wetland, water body, this type of things. Wetland can be man-made or can be natural, but because of their ecosystem functionalities, we are considering them as natural. So these type of natural land covers they are consumed up by cropland in peripheral areas, and in the center, near the core area, built-up is growing in the cost of cropland. So from this, we devised a three-stage model of land use conversion, say for with respect to last 50 years. Say for primarily, the area was demarcated by natural vegetation, wetland, and water body. There are two kinds of transformation. The first major transformation is in the form of cropland, aquaculture, or plantation. That means either they are converting the residents of those areas are converting the areas into agricultural lands, or they are using it for aquaculture also. It is also, aquaculture is also very much part of agriculture. This was the primary, or this is the primary type of conversion denoted by the red bold arrows. There is other type of conversion also, that is from natural areas it has been converted into fallow land. And from, say, the second stage land use also, that is cropland, aquaculture, and plantation, major conversion is towards fallow land. Now, what is the reason of making these fallow lands? It is just to evade the say eyes of the lawmakers. If I want to convert one natural land use into an artificial one, into a man-made one, I cannot do it overnight. I have to keep it as fallow or in an unused part for couple of years, maybe couple of months, depending on the locality, the level of surveillance going on there by the authorities. So what happens that people generally keep it as fallow land, primarily from cropland, or say from, if they are converting directly from natural areas, they keep it as fallow land. I think most of you have witnessed this aspect. When in your neighborhood one pond is filled up, they keep it. Even those promoters, those land hungry promoters, we call them land sharks, they keep it as a fallow land for a couple of years. Then suddenly you see that built-ups are coming up there. So this is almost like a lag period, say gestation period for this kind of thing. So we found this type of conversions going on, and this type of conversions, these are not static in any zone, because what you have seen, that these type of changes are radiating from the urban core. That means over space they are moving from one zone to another, and when they are moving from one zone to another, the intrazonal changes are happening over time. So they are dynamic, these changes are dynamic in both space and time. So this was actually our landscape level analysis, a broad scale analysis, you can say. But from this, it is very difficult to guess what is happening in a particular plot, on a particular site, agricultural site. What are the environmental changes they are experiencing? These are land use changes, these are broad indicators. But what is happening in a particular plot? What is the condition of its soil, its plants, its biodiversity, conservation potential? What is happening there? And also the social and cultural aspects. Because whenever we talk about sustainability, if you study the literature, there are multiple literature about sustainability. The very basic definition of sustainability stands on four pillars, four aspects of sustainability. Primary one is ecological, then economic, then socio-cultural, and lastly, it is actually a new inclusion, that is institutional. Now, it is easier to understand what is ecological sustainability, economic, even most of you can understand socio-cultural sustainability, because I have talked about this thing in last few minutes. But what about institutional sustainability? Institutional sustainability is a very important aspect regarding management of common property resources. When I'm saying common property resources, that means a wetland, that means say fringe land beside a road, beside railway tracks, besides say government housing, the vested lands. These lands are used by the local residents for generations. They are treated as common property. They are used for grazing. They are used for, say, bathing and all other activities, if these are water bodies also. So these common property resources, there is no one to manage it, because government doesn't care, because they these lands generally do not generate that much revenue. People think that it is not my burden, it's not my onus to look after these lands. So there is no one to look after these lands. This is known as tragedy of commons. So there was a group of economists, they studied this thing led by Eleanor Ostrom of Illinois University. They devised one structure of managing these common property resources. They devised some principles how they can be managed, and they emphasized on just on one thing, that the formulation of one management organization, community based management organization, that there should be an organization in the very local level, very grassroots level, which will look after these common property resources, so that there should not be any tragedy, there should not be any mismanagement. And if there is an organization, government can interact with this organization, with the say the local level government officers, the panchayat staff, they can act as liaison officers. So these institutions, or these community based management institutions or organizations, they are necessary to manage these common property resources. If those kind of organizations are present at the ground level, anybody can ask what can be common property resource management organization for agricultural land, because agricultural land in our country is a private property. Yes, there are agricultural farmers cooperatives, there are fishermen's cooperatives. So these kind of organizations, they act as the institutions of management at the grassroots level. These kind of institutions in our country, with respect to our country, they are almost like bubbles in time. They come up, some enthusiastic people form these things, they come together and they make a platform. But after a couple of years, internal feuds crop up, there are vested political interests. These things are taken up by other authorities, and gradually they are the common people who are actually the original stakeholders, they get alienated or detached from these organizations, and that marks the beginning of the downfall of these organizations. So all these four aspects we tried to look after in our assessment. That is, you can say, comprehensive sustainability assessment of urban and peri-urban areas, ecological aspect, economic aspect, and socio-cultural and institutional aspects. All these things were structured in a hierarchical manner. It is under one method called analytic hierarchy process. I am not going into detail of that manner, because this is beyond the scope of present lecture. But in a nutshell, what I can say is that the assessment pattern is such that the major basic concepts, those are subdivided into smaller ones, which can be realized in ground, which can be measured in ground. But even within that, there can be some, these are known as indicators. If it is from ecological perspective, that it is ecological indicator. If from economic, then economic indicator. Even if these are, say, perception based, or it is coming from, suppose I want to know the status of water in that area. So status of water is a vague term. There are several dimensions regarding status of water. The water, physical quality of water, chemical quality of water, biochemical quality of water. So again, these indicators are subdivided into multiple verifiers, which are directly measurable parameters in the field. So we merged all these things together and made a composite index, which will denote which are denoted by several scores, and these scores will mark the sustainability status of each and every urban and pre-urban site with respect to our study area, and this is the outcome of our analysis. From remote sensing based analysis and field verifications, we have identified 72 major patches. There are aerial dimensions also which we have considered throughout this Kolkata metropolitan area. It is under the jurisdiction of KMDA. Many of you, I think, know. So within these areas, there are 72 patches, major patches we have identified, and we have studied all of those. That means it's not a sample-based study, it is a statistical universe-based study. And you can see that from the results, very few sites have actually recorded a relatively satisfactory status regarding the comprehensive sustainability. That means we cannot say that agroecosystem concept or multifunctionality is present in most of the areas. It is present in very few areas. Primarily say this is area known as Mogra Bandel area.
না দোকানটা তার আগে অনেক আগেই খুলেছে। হ্যাঁ টাকাটা দিয়েছে মানে 4,000 টাকা
Devojit,
দিয়েছে।
Someone is
Devojit,
unmute mode. Yes. Someone is unmute mode.
Devojit, please wait. Devojit, please wait. Someone has already sprayed his screen. Please wait.
Yes, no problem.
আমি আবার একটু পরে ফোন করছি, ঠিক আছে?
Devojit, now you can share your
Okay,
screen
thank you.
again. You have to share your screen now.
Okay. You cannot see my screen right now.
No. You have to share it again.
Okay. 1 minute. You just give me 1 minute. Sorry for that.
No problem. Actually, someone has already
Yeah.
shared.
I know. I think it's maybe Oshit Sarkar or Dr. Oshit Sarkar maybe. Okay, now she is me. Dr. Shah, please inform me whether you can see my screen or not. Can you see the screen right now, Dr. Shah?
Now we can share.
Okay.
Now you have to make it full screen.
Yeah. Thank you. Okay, so what I was mentioning is that only 3 areas we have found having almost say almost similar characteristics with that agroecosystem concept. Is that Mogra Bandel area, then some parts in this Baripur, Sonarpur Baripur state, and some parts of this Amdanga area. This is in North 24 Parganas, this is in Hooghly, and this is in South 24 Parganas. Before conducting the field studies, our initial perception was that, and I think most of whatever researchers people do, all of us have some a priori knowledge or concepts rather, that we thought that we will get the worst performing ones just beside the Eastern Metropolitan Bypass, because these are the areas which are prone to rampant land use conversion. But to our surprise, these were not the areas where the poorest condition, or you can say worst conditions were found. Rather, the worst conditions were found in the southwestern part of our study area, stretching from Sakrail Andul up to Uluberi. When we studied the scores in depth, and we found that it is not these type of say poor performances are not coming from land use land conversion scenarios. Rather, these areas are highly characterized by plot fragmentation, then use of outdated technology and chemical pesticides and fertilizers. Most importantly, almost total breakdown of the socio-cultural milieu in these areas. These areas are now suffering from internal feuds and conflicts among farmers and fishermen. These type of things are very prominent in this rural-urban setup. So all these things actually pull down their cumulative sustainability scores. So these are just examples. I am not saying that this is the ultimate study or something. We have to conduct this type of studies with a with an interval of say 5 or 10 years. Then we can actually guess that what is the pattern of change happening in this area. So from not only from this study, from the study of what happening in other parts of India also, or from worldwide studies also, we found that the problem of urban and area-urban agriculture is not primarily of land use conversion. It is primarily what Dr. Mitra has mentioned, that ignorance or unawareness, or what should I say, that our crimes, that means if we maybe we are aware, but still we are doing that thing, then we are committing some crime. It is actually coming from this
Debojit,
aspect. Sorry. Yes.
Debojit, sorry, again I
Yes.
am interrupting.
Uh,
Again, you have to present your screen
okay.
because again some problem
Okay.
has been.
Yes. I think now you can see the screen, Dr. Shah.
Yes,
Okay, thanks.
yes.
As I have already mentioned, that suppose for Kolkata is such a city around which there is no forest area. It is not even a coastal city. There is no so-called natural ecosystem in its vicinity. So how can this city survive environment-wise? And climate is obviously part of that environment. We are aware or unaware, whatever our condition is, we have to understand that these croplands, these water bodies, these wetlands, they play the most important role in giving us the minimum breathing space, in giving us the necessary food. There, there is a worldwide study conducted by the Food and Agricultural Organization, and they have revealed a wonderful fact that almost 40% of the total consumption, food consumption of the urban population worldwide, it is actually coming from the peri-urban setting, not from the remote rural backgrounds. It is contrary to popular belief that those remote rural areas are our food sources, baskets of food. It's not that. The cities are primarily thriving on its neighborhood, on its surroundings. So management of this sustainable management of these remaining farmlands is highly imperative, and we have tried to deliver some site-specific recommendations also. I'm not going into detail of those things because those are highly localized, and people who are not familiar with the names of those areas may not feel very enthusiastic about these things. But the pictures here, I'm showing here, these are actually from across the globe. Suppose this picture in the say bottom center part, this is from Cuba, its capital Havana. This is from Amsterdam. This is from Milan. In Cuba, they are practicing, because Cuba is the world leader in practicing urban and peri-urban agriculture. This is known as community garden. It is mandatory there to have that backyard garden or kitchen garden or community garden. Similarly, in Amsterdam, they are going for mixed farming, even factory farming under, say, greenhouses. This is Milan. You can say the vertical greeneries, development of vertical green walls, and even the roofs are also covered by greenery. This is part of urban landscape design right now. Having greeneries is actually now one, you can say, status symbol. This bottom left photograph is from our own city, it's Rajarhat. They are practicing rooftop agriculture. But these photographs actually talk about, say, the initiatives from middle class or upper class people, upper income groups or middle income groups. There is something elitist in these approaches. But what you can see in that top right photograph, this is from Mumbai. They are using the intermediate lands between two railway tracks to grow their vegetables. Either they are growing for subsistence purpose or they will sell in local market. This is optimum utilization of vacant lands. It is going on. So obviously, we believe it or not, we like it or not, this kind of elitist activities will come up in the imminent years. People will start to grow microgreens in their balconies, vegetables in their rooftops, or if you have some place left, then backyard garden or say community garden. But these are totally urban, small scale initiatives. But what we need, because in cities like us where population is in millions, we cannot only thrive with this type of initiatives. We need initiatives like that of Mumbai, in some areas of Bengaluru also, this type of initiatives are coming up. And our city, Kolkata, is highly endowed naturally. We have our lands. What we have to do is to manage these lands in a more sustainable manner. And all of these management activities Dr. Mitra has mentioned, and by managing these things, we are actually achieving or attaining dual purposes. On one way, we are protecting the environment. In that way, urban microclimate is protected. If urban microclimate is protected, it will have a significant effect on the regional climate. And in that way, locally or regionally, we will feel less impact of climate change. So by this, I want to end my lecture, and I just want to say one or two more things, just to elaborate this picture, because to me, this picture is highly symbolic. This is actually a traditional paddy cum fish cultivation area. It is highly characteristic of the landscape of South Bengal. Anyone who has spent their childhood in the suburbs can relate with this photograph. But at the same time, you can see the advent of urban sprawls in the horizon. Already one land has been taken up for developing some other types of land use. Now it is fallow land. After some years, it will come up as a high-rise or industrial complex, whatever that is. Like these agricultural lands, most of the UPA areas, not only in Kolkata, throughout India, they are waiting for obliteration, gradual obliteration from the map. Hence, it is our duty, it's our obligation as academics, as people who want to perform action research, to do something on ground. We have all the knowledge, we have all the technologies. But this, as Dr. Mitra, we had a talk, and we always emphasized on this thing, that this proper dissemination of the knowledge and initiative from people's perspective. If we can reach those people, those actual stakeholders, maybe some of us are actually the stakeholders, maybe we have the land. So it is not be wise to sell that land. Rather, we have to see how can we manage those lands, and we continue our agricultural activities, which will be economically lucrative and ecologically beneficial. That should be our motto. Thank you.
Thank you, Debojit. It was indeed a wonderful research, I must admit. Urban and peri-urban agriculture is an important aspect in combating so many issues, and you have addressed it so beautifully, considering its economical and ecological point of view. We have heard about it, but were unaware of agro-ecosystem and its implications. We really didn't know about vulnerabilities in urban and peri-urban agriculture. Urban and peri-urban agriculture transformation in Kolkata municipal area is threatening, as we get to know from your talk. You rightly termed it as tragedy of commons. On the contrary, vertical gardening or optimal utilization of land within 2 railway tracks are really encouraging. Thank you for enlightening us again, Debojit. Now, Chandana, it's again over to you.
Okay.
Thank you,
Thank
Dr.
you. Okay. Yeah.
Yeah, Dr. Mitra, go on.
Yes. So what we have for you all here is something which me and Dr. Datta, we wanted to share with you, is different opportunities and avenues for research. And I forgot mentioning, even to, for education, to learn new things. And so hopefully we'll just take 5-10 minutes, and then, we can get into question answers. So here, first let me go ahead and show you the slides. The first one, oh, sorry. I didn't do a full screen, right? Sorry. Is it a full screen now?
Yes.
Okay. So yes, like I was saying, so I'll just share with you the first slide which I have here. But this is a very common one, most of you all know. and even I know, and it's the Fulbright opportunity is something which is it is we get in the US, we get so many faculty members, so many researchers coming to the US through the Fulbright scholarship. So if anyone doesn't know about it, please go ahead and apply because it's very encouraging. And you can see on the left hand side in that particular screenshot which I have, fellowships for Indian citizens. So that's where you will click and you're going to get information on the Fulbright scholarship, the different ways. Please go ahead and apply. And again, this thing me and we wanted to share with you is because assuming absolutely many of you would know this, but still in case if someone wants more information, so that's why we are kind of sharing this information with you. The next one I have here is, please take a note in case this is the University of Washington Tacoma, and this is by chance I came across this website, which actually tells you the different countries where you can go and do research. It could be from a few weeks to months to even a year, and all of them I would say are funded. So it's not that you have to pay much. I'm not very sure if they do the airlines thing or not, but still they are all funded. And what I tell my students always is, okay, you're going to Japan, you're going to Norway, you're going to Germany, and you're going to Slovenia. Who would know their language? Because we are so used to going to the UK or the US for all kinds of research, opportunities. But my students have gone there and they've said that people from all over the world come here. So it's more, it's a fun activity where you don't really need any language. It's more about sign language. So I would encourage whoever the students, especially students, research scholars, even assistant professors, associate or full professors, it's just a mind-blowing opportunity which we have there. And if you can't copy down, I don't know how much of this is going to be retained in the YouTube live, but just remember this University of Washington Tacoma, their website. You can just key the search words as resource, international research opportunities. But this university has a whole list of them, every single one of them. So this is amazing, I would say. A very important one is the German one, which is the Humboldt Foundation. Many people, researchers go there. And again, language is not a barrier. It's just about research and education. Next, Dr. Datta is going to talk to you about some open educational resources.
Thank you, Dr. Mitra. I thought of this sharing you this slide with all of you, especially with the students, because now we are in a completely lockdown format because of this pandemic situation. Although in many areas of West Bengal and India now people are coming out, but for students, the schools and colleges and universities are still closed. So what can they do in this spare time apart from the university exams they are giving? There are lots of resources in the online platform which can be used. There are parallel courses running on either from, say, Government of India's initiative or worldwide also. I specifically request you, that means the undergraduate students or postgraduate students, to go to the website of Yale University and see the Open Yale University page, and you will find lots of courses in that area. Suppose you are not that much interested in studying a separate course parallel to your existing curriculum in the universities or colleges. What you can do is, maybe you have been asked to make a presentation, to make a project report. There may be assignments, and assignments have become more familiar in this lockdown period because we cannot go to the classroom and teach you, and we cannot take direct examination. So the preferable mode has become of giving you term papers or assignments. So how can you perform these assignments without violating the copyright? There are copyright provisions. You cannot just directly copy and paste everything and make your resources. But there are some initiatives known as Creative Commons initiative. You can identify those things by a very simple icon, that is CC, all in caps, CC-BY. If this icon is present in that literature, paper, presentation, whatever that is, whatever resource, video also, whatever resource you are getting, you can directly take this thing and use in your presentation without violating any copyright act. suppose for YouTube videos, there are two types of YouTube licenses. One is the ordinary YouTube license, which gives you permission to study it or to listen to it, or maybe you can use it for your personal purpose. But you cannot use it as commercial purpose, or say if I want to use, I can say it is teaching, but at end of the day it may become a commercial activity also. People can think of that. Suppose someone is teaching in a private university, it can become like that. So for that, these open educational resources, I have given some links here. People who want, enthusiastic people, students, they can take a snapshot, or if it is available in YouTube live streaming, they can take it from here also afterwards. So you use these things and be little bit cautious about what type of resources you are using. Don't go for this blind copy paste mode. Rather, be innovative and use whatever resources are free there. So there are lots of resources. Another thing I want to share, just before giving back to Dr. Mitra. Dr. Mitra, I am sharing my slide just for once. Okay, I forgot to give you one slide actually in the morning. I was in a rush. That's it.
So let me go ahead and unshare what I'm showing
Yeah,
here.
yeah,
Right?
yes, that will be nice.
So stop sharing.
Just one slide, just one slide.
Yeah, sure.
Yes. Can you see the slide right now?
No, we cannot.
Okay. Now I think you can see it. Is it visible?
Yes, it is.
Okay. So these are actually, you can say, a wide array of online courses. These are termed as MOOCs. The full form of MOOC is, I think most of you know, massive online open courses. And most of these, unless and until you need a certificate, these courses are free. And these are wonderful courses taught by the premium institutes, premium faculties. So you just join one course if you have spare time of any topic you have interest, and you will be benefited. I am sure that you will be benefited. So you just take a snapshot, or you take it afterwards from live streaming, or sorry, deferred streaming maybe. So you take this thing and use it for your own purpose. Okay, so Dr. Mitra, now I'm stopping my presentation and you carry on.
Okay, thank you. So one thing, just following up what Dr. Datta was telling, is that a very important thing which he has mentioned, and now it's occurring to me as I was speaking, is this is again for the students. This is not for research scholars who are already a little higher up in their career. But when we actually, even if you're applying abroad, or even if you're applying within your country, and for jobs and other things, it's also important that you have the courses which Dr. Datta was mentioning. These courses, extra courses, or some sort of co-curricular activities. These things will make you stand out from the other person. If you have two people doing the same masters and going and applying for the same job, and then what do we look into it? We look at people who are more active in doing co-curricular activities, or taking some courses which other people haven't. And it doesn't mean that you have to not share or care with your friends. You can do it together, but still, it's not that all your friends are applying at the same place. But I would insist, and I would encourage you that you go ahead and whatever Dr. Datta is saying, go and take some of the courses, not only for your resume, but also just to learn new things. Learning is always fun. So please go ahead and I would absolutely encourage what Dr. Datta has said. So anyway, having saying that, I will just quickly go ahead, and now I know what Dr. Datta was saying, taking screenshots and then maybe later on live. So this particular free data source, this is something which I came across just a month ago, and it is phenomenal. It's really good. So one is this GEOSS portal, which is all about different things about remote sensing, all sorts of data you get on remote sensing from this particular portal. The other one, which is at the bottom of the slide, that is a very recent thing which came out, I think, not even 2-3 weeks back. It is from AMS, American Meteorological Society. It's out through the Bulletin of American Meteorological Society. It's a chapter. which gives you the sources wherever you want any sort of data set, any sort of source, be it aerosol to temperature to whatnot. They have a huge list of all this. So again, please take a screenshot or later on look at the live YouTube live version again. And but these are extremely good sources, and they are mostly all open source. Because one thing which I have realized working here in this country and back in my home country is we have a lot of red tapeism. We have a lot of restrictions in acquiring data. So which is not so mostly in the US or in the European countries. Most of them are freely available. So this actually, the list on the bottom here gives you all sorts of climate data, which are hopefully, I haven't clicked on all the links, but they are mostly open source, right? So moving on from here, and hopefully you've taken the screenshot, whichever, as Dr. Datta had advised. Moving on from here, I'll quickly go through some of the other tools. Now this one is urban flooding and stormwater management. They are free, open source. The top one is more common, which is a SWIM model, which is the Environment Protection Agency's their own model, which anyone can use, not very tough. The other one is coming out from University of Bristol in Australia. It is the LIS Flood. That's also free, so you can use it. The other one is HECRAS, which is a US military, the army, they have prepared this. It's a little, it's got a steep learning curve, but still, it's free. And then you have this whole list of other, urban flood management tools. Some of them are not free, but the country is mentioned from where they are prepared and, publicly available. Then also what we thought, me and Dr. Datta, is just kind of sharing some of these remote sensing softwares which are open source, and some of them are pretty common like Saga and Grass, but there are others which also you can use. And Google Earth Engine is something which is very prominently used these days. So try, and there are tons of freely available resources which will tell you step by step how to use the Google Earth Engine. So I would encourage to look into Google Earth Engine, and they are remotely sensed images stacked up together over all these 30, 40 years. So that's a very good tool to do all sorts of land cover changes. All different kinds of parameters can be analyzed through the Google Earth Engine. The next one is open source GIS applications. There are these list of ones which you see on the left, which you can use. And QGIS, as I've heard and spoken to Dr. Shaha, is the most important and easier one. And R, of course, R is also pretty easily available. But there are other ones also which you can use, and they are open source again. They're GIS application tools. And the last one here is statistical softwares. You don't even ask me what they are, because most of them I haven't used, okay? But they are all open source. And so now, as being students and researchers and scholars, please go ahead and...
Dr. Mitra, only that IBM XPSS, it is evaluation model is actually free. It's not, otherwise it's a commercial software. All other softwares are actually free, open and free.
SPSS, yeah, actually SPSS is not free. You're right,
Maybe in some universities they supply it, but otherwise it's not free. You can use it for say 1 month or something, like in a free version.
Well, free version is only for 1 month. Okay,
Yeah.
Thanks for putting that in. So these are the other ones are more or less free, but like I said, I don't know. I have not used most of them, so I don't know exactly what the output will be. Okay, so that is it with all the information me and Dr. Datta have on all the different resources which you can use for education, for research, where you can go, different countries where you can go and do research, because it's very important. Like I said, collaboration and interdisciplinary research is very important. So not only between your colleagues in Kolkata and in India, but also beyond the scope of India is where fund research actually can be done. So thank you very much. And so I think whatever questions you have for Dr. Datta and me, we are open to answering. Let me go ahead and stop the share.
Thanks, Chandana. Thanks, Debojit, for giving us such an exposure. It's indeed very useful for faculties and scholars. Now we are moving towards question answer session. It's over to you, Asifa. Asifa, please come and join us.
Thank you, Chandana ma'am and Debojit Datta sir. There are some questions for you. First, I want to ask to Chandana ma'am that How do erosions impact on rainfall, reducing its amount?
Okay, so I have explained that in the particular slide. Number one is this whole aerosol and rainfall interaction is very complicated, and that's why I was saying that there is still jury. That means there's still debate on trying to understand how those both of them together work. But when we think about aerosols which do not enhance rainfall but reduce rainfall, the main thing, which the point which I mentioned is because aerosols, not aerosols, so aerosols, yes, aerosols can act as CCNs, cloud condensation nuclei, right? If we have a lot of aerosols, like a particulate matter 2.5 or 10, not so with the 10, let's go with the 2.5, and tiny water droplets, because every single rain droplet, which is the first one which forms, that one is, it needs a medium on which it's going to condense. So if we have too many aerosols in an urban environment within the planetary boundary, say 1 kilometer or a little beyond that, what happens is there is a lot of condensation happening, but none of them actually become heavy or big enough size to be pulled down by the gravity so that they come down as raindrops. They remain floating, and the clouds just go past an urban area, not giving any rain. So it is been already proven that aerosols actually suppress the amount of rainfall coming down on an urban environment. I hope I've answered the question. If any, I don't know his name though, who has asked the
Yeah,
question, but
there
if,
are also some question for you, ma'am. Next question is, as a part of applied climatology along with building materials, is it not that architectural layouts also add to urban heat islands?
oh yes, yes, and hello Moshumi, nice to have you on board here. So yes, absolutely. So when the material, the building material, even the color of the wall, the color of the roof, everything, all this, and how the architecture is made, how the buildings are made, if they have what kind of surface, how many facets they have, all of those actually, they I would say they join together to have an influence on the urban heat island. And just to refer to the people who are here listening is, and even to Dr. Boral, is there is this website, a project, I would say, it's known as a WUDAPT, WUDAPT. It's a world database, urban database, which numerous, faculty members and researchers, everyone is putting together this portal. Again, I repeat, it's WUDAPT, WUDAPT. And what they're doing is they're going around and asking people to use cell phones to take pictures of how the wall is, what the color of the wall is, what the color of this is, and what material is used. Like look to your left, look to your right, and even sky view factor. Many, many elements are being input into that WUDAPT model. So if anyone is interested to see how architecture and urban climate and urban heat, they all play a role together, you can visit that website and learn more about it.
Okay, ma'am. There's another question for you. That is it possible to study the UHI or microclimate in a small Indian city with 2 lakhs population, where most of adjoining rural part of the city has lateritic land cover?
Yes, I think it can be done. Now, there are two restrictions. One is the general tendency of doing a surface urban heat island study is using remote sensing. But the problem is with be it MODIS or be it Landsat, the resolution is going to be too big if it's just a very small city which just has 2 lakh population. So remote sensing may not be the right method to assess urban heat island intensity of a very small city. So the other thing what you can do, the particular researchers asking the question, is you can use these pretty cheap eye buttons, temperature measuring eye buttons. And they are not that expensive. I cannot really tell you how much they cost in rupees, but I know researchers in presidency, and I don't know if Dr. Datta has used it, but I have used it, and me and Dr. Datta, we have tried doing a project together. Unfortunately, because of COVID-19, it failed. Where he and his students, we all did it together. But anyway, I took the eye buttons from you, so I cannot give you the price. But the other thing which you can do is use these eye buttons and you can place them around whatever small little, 2 lakh population the city you have, and that would actually give you a pretty good assessment of urban heat island intensity. I hope I think I've addressed that question. Any other suggestion? Do you have any suggestion as to any other ways or means in which we can measure urban heat island or these kind of measurements for smaller cities?
No, I
Right.
think
Have I
you have covered everything actually. The problem is that he is mentioning laterite soil in the outskirts. What will happen that the outgoing radiation from these laterite outskirts, they will have a major impact on the, say, if we only rely on satellite imagery, then this huge amount of radiation coming from the laterites also, because most of them will be in a, say, bare surface mode. So they will actually reduce the urban heat impact. So it will be very difficult to segregate between the bare earth signal, bare earth spectral signature, and say urban signature in a thermal mode. It may be possible in an optical mode, but thermal mode it will be a little bit difficult. So that was his point of view actually. So I think
Yes.
you have addressed the problem. It should be done on, say, in a field basis. Too much emphasis on remote sensing and GIS is only going to ruin our geographical pursuit. There should be a mixed medium. As Dr. Mitra has also elaborated, maybe from my study you have seen that you should be open-minded in choosing your method of study. Method is not ultimate. Your objective, what you want to achieve, that is actually the real thing. According to that, you select your method. So don't blindly follow the remote sensing method. There may
Right.
not be any fit.
Yes, and I think you're right. So it's very important that we use a mixed method, because we always go for the easy one. And what's happening is, and even when I'm using models to kind of assess or do anything for urban areas, we need ground truth data for validation, be it remote sensing, be it any kind of modeling study. You cannot really publish a paper, or you really cannot validate yourself if you do not have anything observational. So I really, I'm with Dr. Datta on that try to use mixed methods, but in that particular case, and thank you for alluding on that, Dr. Datta, about the laterite soils, I forgot that section of the question. But in that case, the eye buttons would be a cheaper way, not very expensive, cheaper way of understanding the urban heat island of that particular city which you have mentioned or asked in the question.
Okay, there is another question for you, Chandana ma'am, from our very own Dr. Joyita Mukherjee ma'am from Department of Political Science. That the question is that what should we do to reduce our carbon footprints?
Oh, a lot, because individually, and I think individually, for me actually, then I have to start flying to Kolkata, which is not possible at all. We have to take less flights to wherever we are going, and COVID-19 has proven that, the least amount of flights we can take, that's the worst, I would say, carbon footprint. But then not deviating from the question, I think, like I said, we have to, charity begins at home. So let's begin from home. Number one is even small little things, not using plastic bottles, because I've seen when I go to all these marriage parties and all birthday parties in Kolkata, the newest trend is always using these small little plastic bottles. And we don't realize that the carbon footprint of that small bottle of water is huge, right? So, and I'm talking about individual scale. So then when we move into a little higher up, it could be more about, policy changes, which doesn't always happen. So there is this knowledge transfer gap, and where I was mentioning, and we have discussed with Dr. Datta also earlier on, is that we do not really talk to the government. There's a huge gap in the communication between the government and the stakeholders, the architects, the planners, and even geographers. We do so much work on, urban mitigation and different kinds of aspects of urban climate. We need, and in Hong Kong, they actually have this, they call urban climate maps. So it's the government actually is reaching out to climatologists, to architects, and to planners. They all come together, put their heads together, and they work on different projects, which is missing as to my knowledge. And really, I'm not really working on the ground in Kolkata or in other cities in India. And you other people can chime in, but I think that's missing, which is doing joint work together. So I don't know if I've addressed the question, but so these are certain ways. We can do individual ways of trying to mitigate. We can do it for the community. Like for example, in the building where I live in Kolkata, there's constantly, whenever there's rain, there's waterlogging in the garage area where the cars are. Why? Because we've removed all the green areas and made them concrete. So the outside is dry, the streets are dry, but we can't even step into the parking area. It's full of water, like around half a feet of water every time we have rain. So I tried, failed, but anyway, it's all about communication. So whatever you're learning in your research, just go out and talk to people, talk to common people. That's the first step, baby step towards mitigation. Well, thank you.
Okay, there is another question for Debojit sir. That is, what are the differences between urban and peri-urban areas?
Okay, I think I have dealt with that in the very beginning of my slide. Urban areas, suppose to be designated as urban, there are certain norms. The norms vary from one country to another, but in general, there are certain norms, primarily depending on population density, depending on the people engaged in non-farm activities. Then there are land use wise definition. So many definitions are there. But peri-urban area, as we have showed here, that this is actually a transitional area where the core urban area ends and the rural influences begin. So it is very difficult to demarcate these areas with traditional methods. You have to, as Dr. Mitra said, that you have to use mixed methods. That you have to go for remote sensing based assessment to denote that, to identify the land use land cover change. You have to go for environmental monitoring, that in urban area we are expecting this kind of environment, and in rural areas we are expecting this kind of environment. So where does the intermediate line? It is in say ecology. If I take an analogy from the biology or say ecological sciences, it is an ecotonal area between the urban and rural areas. It denotes the gradual change of land use, of social character, social ethos, the economic activities, and also you can say the environmental characteristics. This part was not studied in detail earlier in earlier times.
Okay, thank you so much,
Okay. Okay.
ma'am
Thank you.
and sir. There's no other question left.
Thank you.
Thank you so much.
Thank you, Asifa. Thanks, Chandana and Debojit. You have wonderfully addressed all the questions raised by the participants. It's really appreciable. Now, I would like to request Srimati Sanchita Gupta, joint convener of this webinar, to give vote of thanks. Sanchita.
Thank you, Shrijiti. Am I audible to all?
Yes,
Am I
Sanchita, you
audible?
are audible. You are clearly audible.
Okay.
Yes.
In fact, we were so engrossed in this insightful discussion that in fact it made us forget and be unaware of the geographical distance and variance. But now it is the time for a formal vote of thanks from our part. I, Shantita Gupta, on behalf of the Department of Geography of Women's Christian College, take this opportunity of offering our humble vote of thanks for the international webinar on climate change and urban environment, pattern, externalities, and mitigation. We express and convey our heartfelt gratitude to our honorable resource person, Dr. Chandana Mitra, from Auburn University, USA, for her illuminating presentation. You are indeed an inspiration for all of us, madam. Thank you once again from our side. We are also offering our heartfelt
gratitude to our second resource person, Honorable Dr. Debajit Datto from Jadavpur University, Kolkata, for his inspiring and highly relevant deliverance. Thank you, sir. On behalf of the Department of Geography, we are indebted to the honorable members of our college governing body. Of special mention is of Dr. K. Mandi, Honorable President, Srimati Shagorika Banerjee, Honorable Vice President, Dr. Rosna Pandey, Honorable Secretary of the College Governing Body. We extend our gratitude specially to Honorable Governing Body members Dr. S. K. Mukherjee and Dr. Srilekha Kormakar and each and every respective member of the governing body for their constant support and encouragement. No endeavor is complete in our institution of 75 glorious years without the constant motivation and guidance of our respected Principal Madam, Dr. Ajanta Hall. Thank you, Madam, for everything. A special note of thanks for all the honorable members of our college IQAC. Especially thankful to all the respected participants consisting of faculty members and research scholars associated with various esteemed institutions, not only from our country, India, but also from abroad. We are inspired by your enthusiasm and gracious presence. We are also very much thankful to our college colleagues, all the teaching and non-teaching members of the Women's Christian College family, and we extend our heartfelt thanks to all the faculty members and non-teaching staff for their active participation and constant support. Organizing a webinar on digital platforms would not have been possible without the technical assistance and guidance offered by Dr. Somnath Hajra, Assistant Professor, Department of Education of our college, and also Srimati Kamalika Basu, Assistant Professor from Department of Geography, Vijendralal College, Krishnanagar, Nodia, and who also happens to be an ex-student of our department also. We are also thankful to all the student participants from not only our college but also from different institutions for their active involvement and their presence. In fact, we may have missed out on some names, but whoever actively or from behind the screen have supported us, have guided us in organizing this seminar, we are thankful to all of them. We hope and pray that the discussions and the exchanges that we make today on a very relevant topic will make this world a better place and in fact a safer place to live in, and it will make us think, do more research work, implement our research for maintaining climatic sustainability of the cities and their surrounding areas. In this present situation, we again pray everybody stay safe, stay healthy, and thank you all once again for being with us in this international webinar. Thank you all.
Thanks, Kunchita for such a heartwarming vote of thanks. Now we have come to the end of our webinar, and it's the time to say goodbye to all. Thanks, Chandana, again. Thanks, Debojit. Now we are ending the webinar from our side. Thank you all. Bye.
Thank you everyone. Thank you, Dr. Shah and Dr. Gupta and everyone there at Women's Christian College. My pleasure.
Yeah.
Thank you.
Thank you, everybody. And thank you, Shejiti and Sanchita ji, for arranging this one. Thank you.
Okay. Now we are leaving. Okay, we are leaving. Okay.
Bye-bye.